games with a buddy pretty soon. Alright, but we gotta take some. Alrighty, so let's now start on Minimal Tree, Chapter 4.2. Minimal Tree. Okay, so first let's just create the prom. Chapter 4. So like I said, I mean, I don't think I'm able to finish all these proms, honestly. And so what I think I'm going to do is basically just iterate, cycle through Chapter 4, Chapter 5, Chapter 8, Chapter 10, maybe Chapter 15 and 17, or 16 and 17, whatever the moderate and the hard proms are. Yeah, 16 and 17, I believe. I'm just going to cycle through those basically over and over again. And so, you know, I mean, if I'm going to do that, then I should go to Chapter 16, actually. Okay, yeah, let's do that. So let's do Chapter 16, actually. Change my mind. Because I haven't yet done a prom from Chapter 16. Alright, 16.1, Number Swapper. Write a function to swap two numbers in place, that is, without temporary variables. Nothing really comes to mind on this one. I hope this isn't a... This sounds like it may be a bit manipulation prom, which I am largely comfortable skipping, because I think those are probably a waste of time unless you're doing system programming or interface drivers or something like that. Let's say that I'm just going to spend 15 minutes on this, and if I can't even think of, so until 10 o'clock, and if I can't even think of anything to do on number swappers, I'm going to just I'm just going to look at the hints and figure out what I'm supposed to do. Yeah. Maybe less than that, honestly, if I really just have no idea, which currently I don't. Alright, so, see, last one I think we did is chapter 10, right? Yeah. Tried making the text a little bit bigger, too. Okay, so... just get this thing running. Alright, cool. And... Alright. So, the problem is number swappers. You know, I don't even think I can do this problem, really. I'm just not even clear what this problem is asking. Number swappers. Write a function to swap two numbers in place. That is without temporary variables. Do they mean, like, is this some sort of bit shifting thing? Or do they just mean literally switch the symbols? Oh, that all comes. Because, I mean, I can only redefine new symbols in a lower enclosure. Yeah, I'm not even clear what this is asking for, so... but I guess it specifically says numbers, so that's probably important. The fact that they're numbers. Okay, the fact that they're numbers. Okay, that gives me some thought. Okay. A and B. So... I don't really know what it means to swap a number enclosure. what would the test for this be? It'd be like, I guess it would be like, I mean, but like to truly swap a number is just like, what does it mean? Is this a swap if I do this and return this? I mean, that's a number swapper, right? Swap the two numbers. But I think what they really mean is if you're passed two symbols, A and B, and the value at A is now the value at B, and the value at B is now the value at A. I mean, that's really not possible in Clojure, but it just doesn't make any sense. But what we could do is, I mean, first of all, there you go. This is I think, just a dumb problem. Let's just see what we're supposed to be doing. But what could we do? Okay, let's just talk about what if we did have a mutable language where we kind of change the value at symbols at runtime. Then, because we're talking about two numbers, there must be a delta between those two numbers, right? Because we have a delta, like bit manipulation stuff, I think... I feel like you can add the delta to one and subtract the delta from the other, but that requires another variable, doesn't it? The delta variable. Two numbers. Is there some sort of AND trick, or if I AND the numbers together, I'll get something? This is not interesting. I'm just going to look up the solution. 462. Oh, the hint, actually, first. Oh, that's the solution. Actually, let's look up the hint. 491. Try picturing the two numbers A and B on a number line. Okay. So we did. 715 is the next hint. Let diff be the difference between A and B. Can use diff in some way. Then can you get rid of this temporary variable? Okay, so I got that far. Basically, recognize that there's a delta between two numbers. But how do I get rid of that temporary variable? I mean, okay, so hint number 3, 736. You could also try using XOR. I felt like something there. Okay, well, exclusive OR says that the two things need to be different. If the two things are different, then they'll be true. If the two things are... If the two things are different, then they'll be true. If the two things are the same, they'll be false. So... I'd really have to think about that, honestly. It's probably really obvious to somebody who knows that stuff, but yeah. Let's just run through a few examples. Maybe in binary, right? So 1 is just this, right? 2 is this. 3 is this. 4 is this. Okay. So if I want to swap 1 and 3, which let's just make them all 3 digits long. If I use the exclusive OR, okay. I mean, it should technically return just the swap of these two, right? Oops. And 0, 0, 1, right? Should have just swapped the two of them. But then, okay, the exclusive OR of the first bit, 1 and 1 is false. Okay. Well, or what is the exclusive OR of these two things? Let's just start with that. Okay, sort of ignoring this for now. Right? What does this give you? It gives you, if they're the same, it's false. So false, they're different, true, false. Okay. False, true, false, okay. And then it kind of looks like maybe this one is just the OR, and this one is just the AND. I don't know if that's a property or not, you know. Let's just do that again. So let's do, let's do 7 for, or 4, 2, 1, 0, and 6, I guess, right? 7 XORed 6 gives you, I guess that gives you the same thing in the remainder, right? But anyway, 0, 1, oops, 0, 0, nope, 0, 1, 1, Jesus Christ, 0, 1, 0, 1 is what I think it gives you. It's the same here, or it's different here, and it's different here. But it's the same here, second position, same here, first position. Okay. Yeah, so that's what the exclusive OR gives you. And so that should mean you should get, if you use the exclusive OR as the AND for the first one. What was it? Was it the AND for the first one? No, it's the OR for the first one previously. Use the OR of the exclusive OR and the original 110, 1110, 0, 11. Zero, 1, 1. Yeah, okay. So OR should have more bits set, and AND should have fewer bits set, right? So anyway, the OR of 1, 1, 1, 0 should now just be, well, that doesn't look right, does it? Well, that's because that's not 7. Okay. 1, 2, 4, 8. 8 plus 4 is 12, plus 1 is 13. Okay. 1, 2, 4, 8. 8 plus 2 is 10, plus 1 is 11. So we have 13 and 11 is actually what we have here. Okay. Okay. So and we got the exclusive OR 0, 1, 0, 1, and then we can also union OR them together to just get. It certainly doesn't seem like we should get anything bigger. That seems very suspicious. 1 is the same, so that should be false. 1 is different, so that should be true. 1 is the same, so that should be false. And 1 is different, so that should be true. 0, 1, 0, 1. This is the value 5. 2, 4. This is value 5. Okay. Yeah. Boy, I think this is a waste of time. But, let's see. So why isn't this working? I'll do the OR on both of them just to see if I got it backwards maybe somehow. But the OR of 1, 1, 1, 0 and 0, 1, 0, 1 should be just all ones. Right, so that can't be right. Is this actually the... I mean, this one looked like it was the OR of this and this happened to be this. This one happened to look like the AND of this and this. Well, it was not this actually. So okay, so that was it. We do have the OR. All right, so if we have the OR, is there anything you can do with the OR to then get it back to the original? It's like the AND and the NOT, or the OR and the NOT, or something. I don't know. Let's just try putting random things together. There's only so many things we can think to do that don't just end up being themselves again, right? That's not true. OR is destructive and AND is destructive. NOT is not destructive. No information is lost in the NOT. XOR is also destructive. You can't. Yeah, because you lose. All you know from the XOR is whether you have the original or whether the two were the same. And or not. I hope I don't get a problem like this. And or not. Think. Alright, this one plus... Okay, this one and this one. What does it give you? Oh, this one happens to give you this if you do the OR. But I don't think that's actually a true statement. I think it's just coincidence. So let's just write them all out. OR of these two guys is 1, 1, 1, 1. Or this is 14. And this is 8 plus 2 is 10, 11. And this is 15. Okay, that's the OR for the first one. The OR for the second one is also 1, 1, 1, 1. So I don't think that goes anywhere. What about the AND? The AND for the first one is 0, 1, 0, 0. The AND for the second one is 0, 0, 0, 1. I don't see anything magical there, honestly. Oh wait, I do see something there. This is interesting. This AND, if we knot it, is this guy. This AND, if we knot it, is that guy. So that is kind of a swap. So let's just make sure that's true. The knot of the AND, not really, that's the real syntax here, but is 1, 0, 1, 1, and then 1, 1, 1, 0. So I get that NOT is not a destructive operation. So I get that that does not delete information. But it sure seems like exclusive OR I mean, information is lost when I exclusive OR, right? So how can that really be working? Because, like, if I have 1 bit, if I have 1 bit and 1 bit, I could either have 1 bit and 1 bit or 0 bits and 0 bits to get just the 0th bit, or I could have 1 and 0 or 0 and 1 to get the 1 bit. So, but information is lost because I had 2 things that become 1 thing. So how can XOR not, XOR, how can XOR not be deleting information? Really, it's more like, I guess it's between these 2 things. Oh wait, this is really supposed to be, but just like the logical notion, there are 2 things. Oh, whatever. I'm making this confusing, but let's do commas, right? Or, I don't know. Different use of the word or here. Either these 2 inputs result in this, or these 2 inputs result in this, or these 2 inputs. So that information was lost here. But I guess maybe combined. If you combine it with the information that's also lost here, right? Because I mean, obviously information is being lost here as well. 1 and 1 is the only thing that gives you 0, right? Or sorry, is the only thing that gives you 1. And 1 and 0, or 0 and 1, or 0 and 0 all give you 0 for the AND. But evidently the combination of those 2 things does not result in the loss of information. It's a reversible thing. Well, then let's just go through the XOR AND, I guess, just to try to understand that. Or it's not that it doesn't result in the loss of information, it's just that it actually ends up... Well, no, let's talk about the loss of information, right? Ultimately, if the only way you can not lose information, if it's never the is if every single case results in a 1-to-1 mapping, right? If there's an OR here, like the exclusive OR has to lose information, because I don't know whether the original input was 1, 1 or 0, 0, and definitely results in the loss of information, because this guy maps to this and everybody else maps to that. Not results in no loss of information because it just inverts, right? I'll just write it out, results in 0 and 1 results in, oops, I got it back. So there is no loss of information there. Yeah, it's obviously not a valid closure code. But yeah, I'm just not quite clear why that would work, honestly. Like why would... So XOR, the one that XOR actually does coincide on, I feel like the only way I'm going to just figure this out is to actually do it for each one. So if you have an input of 0 and 0, Oh, but what's a good test for this? I got one, right? Okay, so that's fine. Oh, this I got a better thing to do on this one, even though it's a. I don't think this is a. I hope that we're not going to do bit manipulation stuff because I don't know. Anyway, but what are the four starting positions, right? You can be, you know, we're just going to put x's in here for now, but right, you can be 0, 0, you can be 0, 1, you can be 1, 0, you can be 1, 1, right? Let's just see where and we're just going to call function the thing between the two of them, right? Because right now it's it's our own little function, right? But what it really is the it's the XOR of x and y, right? And then it's also okay, so the XOR of x and y gives you basically what is different between x and y, right? So the things that are true are the only things that you need to flip, right? The things that are not XORed are the things that you can leave alone because there's similarities between x and y, right? And then what are we saying? Well, we're saying give me the and of x, I believe, and XOR of x and y. And then we're saying give me the not of that, right? Let's not use. I don't actually know what you call. I've never used the bit manipulation things in Clojure, but I'm gonna just make them big like this to make it clear that we're not talking about necessarily. Okay, so for 0 and 0, the XOR of 0 and 0 would be 0. For 0 and 1, it'd be 1, 1, 0. So I'm going to say, what about... Well, actually, I'm just going to write the whole thing out. The XOR of 0 and 0. How do I want to do this? I don't have a good way to write this. Actually, I do. Okay. Undo everything I did. We're going to just basically just copy this multiple times. And rather than doing, since I'm only talking about one bit at a time, I'm just going to do not, and since each bit is entirely independent from either other bit, this isn't like sum or add, this is just bit. Right? This becomes XOR is false, right? Becomes this. Becomes the and of this, which is also false, or 0, and becomes 1, right? 3, 4. And similarly, 0 and 1, 1 and 1, 1 and 1 and 1. right? Okay. So this becomes the AND of 0. The XOR of 0 and 1 was 1, right? The XOR of 1 and 0 was 1, and the XOR of 1 and 1 was 0. Okay. Oh, but in this case, XOR of X is actually 1. No. Yes. But the value is actually 1 for this too, right? X is X here, Y. Should have actually done the first one with just X and Y's to make it clear. I guess I did do it right there. Yeah, okay. Then the not of the AND of 0 and 1 is 0. The AND of 1 and 1 is 1. And the AND of 1 and 0 is 0. So it seems like we've just mostly destroyed most of the information here. But the not is going to be 1, 0, 1. Does that make any sense? So if I started with 0 and 1, if I started with 0, I'm going to get, well no, sorry, if I have 0 and 0, I'm going to get 1. I don't feel like this works, honestly. Okay, so let's think about this. Did we switch two variables? Did we switch y into x, basically? If I do this, did y become x? No, it did not. If I do this, did y become x? Yes, it did. If I do this, did y become x? No, it did not. If I do this, did y become x? Yes, it did. But this did not work. Let's make sure we did the math right here. And of 0 and 0 is definitely 0. And the not of that is definitely 1. Yeah, okay. So I don't know what I'm doing. I mean, what do we need? What does it mean to switch two numbers? Well, it needs to, I mean, it really means logically, I need to change all the bits in your number into the bits in my number, right? So the only bits I should need to flip are the bits that are different. Or, in other words, the bits that are exclusive or true, right, is the only bits I should need to flip. Right? Yeah. So, if I'm flipping only the bits that are different, then yeah, all I gotta do to go from one bit stream to another, or bit sequence to another bit sequence, is flip the bits that are different, which is what I get from the exclusive OR. So don't I actually, maybe I want to, do I want to flip? Okay, I can use the exclusive OR between two bits, between two sequence of bits, to get the bits in that sequence that are different, right? And so therefore I know for the first for the first sequence, I want to flip the exclusive OR of the differences of the two sequences. I want to flip them. Well, I know they're different, but I don't know what they were. All right. And so basically, yeah, I just want to flip them to whatever they're not, but only the ones that are the same. But only. Without temporary variables, okay. I know what parts are different. The exclusive OR gives that to me. Okay. Let's just write that down as a XOR. Gives, oh my gosh, gives me the, oh my gosh, the two bits that are different. All right. If I got the parts of the bits that are different, I just need to sort of build I guess kind of like a mask or something. Word I've heard used before. And any bit that's in my mask that's set to true, I want to flip. But how do I do that? How do I flip a bit? Well, I take its complement. But then okay. So I can grab all the bits at that location using the exclusive OR, right? And then I can grab all the bits at that location using the exclusive OR, right? Then I can flip, then I have I can flip all the bits, right? Then I can grab all the bits at that location again using the exclusive OR. And then I can union, intersection. How do I put them back in? I don't quite see that, yeah. Okay, so I can grab the bits that are different with the exclusive OR. Then I can AND them. Well, so then I got the bits that are different, and I just need to take the complement of those, right? And that's well, no, I need to take the I need to grab them. I need to grab the bits in the original X or Y that are different, right? Um, and I can do that with a so if with I'm gonna use this sort of syntax, and I'm gonna just say A and B rather than talking about any particular bit. But A and B are both straight sequence of bits. So XOR A and B gives me the parts of the A and B that are different, as bits. Then I can take I can actually grab out of let's say for X, for X that we're trying to get Y into it, right? I can grab from that. Sorry for A. I can grab from that the and of B of XOR AB, right? So now I have all the bits. Well, no, I don't really care which one. I guess if I grab the B's, yeah, if I grab the B, then I don't even need to if I grab the B, then I don't even need to, well now I don't need to flip them actually, because I can just grab these bits out of B, right? And now I have a sequence of bits. So this gave me the sequence of bits that were the different bits, right? Where all the different ones are set to B. Then I grab those elements out of B itself. And now I can OR or I want to literally overwrite at each of these bit locations. I want to overwrite any bit I have in here that's in this mask. I want to actually overwrite. Any bits that's in here I want to overwrite. So what I have here is the correct delta. That is, these are the things that should be written into the new value, but I don't really know which. Oh man, I'm really bad at this. Okay, how do I put this into the original A such that only the values that are, well, there's no distinguishing those. There's no way to do that directly unless you also sort of remove all the I need to make them exclusive, I think is what I'm saying, ultimately, when I think about it. So I need to make it so that the current A okay, so here's the same two function twice, XOR AB, right? And that gives us the things that we want to remove. And that gives us the things that we want to remove. Or, sorry, this gives us the things that are the delta between, sorry. Other things are happening on other screens. This gives us the things that are the difference between these two. But then I need to only keep from A the things that are the same. Right? And so that's the complement. Right? The things that are the same are the things that have current value of 0 on the XOR, right? And so I'm going to keep all the things that are the same, right? And so now everything that is not the same, right, is false, and everything that is the same, or 0, and everything that is the same is 1, right? And then I'm going to take the complement of that and A. And so now I have a sequence where everything that's the same has its value set, and everything that is not the same has its value set to 0. You know, I'm going to do the same thing for B, but just for the delta, right? So now we get what is different, and so we got the values that are 1 are the same, and the values that are 0 are different. And then we're just going to AND that on B, and so you're only going to get the things that are different. These are different sets, right? Or these are non-overlapping, basically, these two things, because of the fact that we use this XOR thing as the root that we started from. And then I think you can just take the OR of that, right? And now because you know these two things are non-overlapping, you know that they're not going to override each other, I think. And that's A, you know, and you do kind of the same thing for B, except just kind of reverse everything a bit, you know. So I guess let's just write it out. And B and A. Okay, that's cute-ish, but that doesn't actually solve the problem at all, because we obviously did create a temporary variable. Well, first of all, we created, conceptually, I feel, multiple temporary variables as we just did each of these, right? But then furthermore, by doing A, we've clobbered A. By doing B, we've... Well, but have we clobbered it in such a way that we actually could reverse it somehow? I don't freaking know, you know? Um, and yeah, I think that's as far as I'm going to go on this. Let's look up the answer. All right. Solutions. Chapter 16. All right. All right, number swapper. Write a function to swap two numbers in place, that is, without temporary variables. Oh, wow. It's completely different than what I thought it was. It wasn't... Okay, so they are calculating the diff, right? Where A is greater than B. Okay, we set A to the difference, which is the right side of the number line. Okay, so if you have A and B and A is greater than B, you just set A to the difference, which is the right side of the number line. Then we add A, we add B, and diff, and store that value in B. So we still have A is the diff in B, and we add B and diff, and store that value in B. We get A 0. We now have B equal to A, and A is equal to diff. All that's left to do is to set A equal to A minus diff, which is just B minus A. Oh wow, that is not even, I wasn't even coming close to that. Okay. Sorry, just reading. Okay, so I did think of using the XR, I guess, but... Wow, evidently you can just XOR it 3 times, and that'll basically just do it. No, sorry, never mind, I'm misreading the top part. You can XOR on A, then you can XOR on A with B, and assign that value to A. Then you can XOR A and B, and assign that value to B. And then you can XOR A and B again and assign that value to A. Huh. Oh man. I would have never reached that conclusion because I wouldn't probably have walked down the path of even thinking of changing the value of A as an intermediary, you know? Or using one of these two things as an intermediary, right? I would just think you gotta do everything in an expression and then write the result into the value, and then it needs to be done. But yeah, that's interesting, isn't it? Huh. Well, weird. Okay. Well, let's just. I guess let's try to. Well, I guess at least learn the minimum of bit manipulation functions in Clojure. Manipulation in Clojure. Oh, so we call them bit and all these things. Okay. So does this one mean XOR? Okay. Alright, cool. Well, let's just at least, I guess, kind of write out the solution. So let's try to write out mine and see if that even works. So yeah, I think the right way to do it is to do this, right? They pass in B and A, then return, or a vector with A and B, then return a vector with B and A. That's the correct solution. But if they pass in A and B, and you actually want to, for some weird reason, not actually, like what is the closest equivalent I can think to writing this? Okay, so we can say, well, like you really don't change values in Clojure, so I guess we could just redefine it every single time, right? So that's the closest we can get. It's just redefining it every single time. So they're claiming that if I do this, I can say A um, is equal to A minus B, right? And that's the delta I'm putting in A, right? Then I can say B is equal to A plus B, right? And so now I'm adding into B the delta of A, or the delta of AB. And then A is equal to B minus A. And that's that. And then, so finally I'm going to just return the same AB, but they've been redefined to be negatives. Let's just see if that's even true, okay? So, okay. A and B, output. So, you know, we're going to actually define this as just a vector. Not actual, but in, whoops, whoa, come on. Expected and input, and let's just do input and, or expected and input. I guess there's really no need. I guess I kind of feel like sometimes I put the expected at the front because that's kind of where it shows up in the equality thing as well. But there's no need, you know, we can just say input and output. Or input and expected, right? And so that kind of means, and if, but of course if I do that, I kind of just like the convention of I guess the convention could just be that the last argument is what you expect, and everything previous to that is your inputs, right? Your arguments. So I don't know. Let's just do it this way for now. So let's just do, like, if we do, okay, so this is easy actually. If we do 23 and 6, or 7, I mistyped, then we should get 7 and 23 as the result, right? So now if we do, I guess we're not really going to handle not putting 2 values in there. With a blah blah and 14. Result symbol or. Yeah, that's probably true. Okay, so we got a lot of stuff in here. That was just me sort of thinking it through. Okay. So A and B should be redefined, but it wasn't. But that is because... Oh, I didn't actually flip them. Alt-T. Okay, so that works, but what about when we put the first number as smaller than the second number? Oh my gosh. That also works, okay. So smaller is bigger than... Well, what was this nonsense about being on the number line? Why does that matter? Or sorry, why did it... Let's picture these number lines for the cases. Like, so it's not that it's a requirement that A is less than B, it's just that just happens to be what they're illustrating. Okay, well that's cool. So that's one solution. Number swapper, arithmetic, I guess let's call it. Arithmetic. Bitwise. See if we can get this one to work too. It's going to be basically identical, but actually, let's just do it this way. So now A is going to be equal to evidently this bit XOR, I think is what I said. Yeah, bit XOR of A and B is equal to A. Then B is equal to the bit XOR of A and B. It's A now is for the bit XOR of A and B. Oh, there you go. You know, I mean, that's cool. I don't think I would have really thought up that solution, at least not soonish. And that, yeah, I really wasn't looking for solutions that involve redefining A. Like, I think of things in terms of like building an expression and assigning, and that expression returns a result. Like the idea of like using A and B as intermediaries as I copy them over. Yeah, it just wouldn't have occurred to me for a while, honestly. I guess for this one, well, let's try out my solution, see if that even works too. And if not, then let's just move on because I'm kind of bored with this. A and B, right? I guess we just copy this pretty much this pattern. But not really actually, because really I'm gonna say right. So swap them A and B. I guess swap them. B and A. Right. And this is just going to take something that something looks like this, right? So this will be bit or, this will be bit and, this will be bit not, bit XOR, this will be bit and, this will be bit XOR. Does that have any chance of working at all? Well, it certainly does if we don't test it. Yeah. So I guess it is right, but yeah. So there you go. But it doesn't. Wait a minute. Why does that even work? Oh, because I'm not really redefining the symbol itself. Yeah. So it's not like I actually made any changes to the A and B you passed in, which I think is better and smarter and like, not that this is better. I mean, this is obviously pretty clever, you know, but yeah. Okay, so, well, you know, I think that was a bit of a dud in terms of testing, or a dud in terms of work, but oh wait, CK. Come on, come on. Stop. Okay. So this is called, what was it called? It was Number Swapper. Chapter 16.1. Oh, crack in the code area.